Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 5 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2749. Minimum operations to make the integer 0. So let's read the problem statement. You are given two integers num1 and num2. In one operation, you can choose integer I in the range 0 to 60 and subtract 2 power I plus num2 from num1, right? In one operation, right? We have to return the integer denoting the minimum number of operations like above needed to make num1 equal to 0. If it is impossible to make num1 equal to 0, then in that case we have to simply return -1, right? So we have to return the minimum number of operations, and in one operation what we have to do, we have to choose any integer in the range 0 to 60, any integer I in the range 0 to 60 and subtract 2 power I plus num2 from num1, right? Okay, now see this example number 1. So num1 is equal to 3 and num2 is equal to -2. So here we have to subtract 2i plus num2, right? 2 power I plus num2. Num2 here in this case is nothing but -2. Okay, this is what we need to subtract from the original number, that is nothing but num1, right? Okay, so here in the explanation you see we can make 3 equal to 0 with the following operations. These three equal to 0 with the following operations. So first what we have to do, we have to choose I is equal to 2 here, right? So if I choose I is equal to 2, then what we are going to subtract, we are going to subtract 2 power 2 plus -2, right? This part. And here if I solve it, 2 power 2 is nothing but 4, 4 minus 2 is 4, 4 minus 2 is nothing but 2, right? Okay, 2. So this is nothing but 2. So this 2 I need to subtract from num1. So 3 minus 2 is nothing but 1. So this is what we are going to get, right, in one operation, right? So now this is my new num1. This is my new num1. So here I am writing this new num1, and again now if I choose I is equal to 2 again, and here then again I am subtracting this 2 power 2 plus -2, that is nothing but 2 only, right? Okay, so here 1 minus 2 I am getting -1, right? So here in this operation I was choosing 2, here also I am choosing 2, right? Okay, and next time now new number is -1, this number, right? So here this is -1, right? And from this now if we choose I is equal to 0, so I is equal to 0, just place 0 here. 2 power 0 is 1, 1 plus -2 is nothing but -1, right? So here -1 minus, and here you are going to get -1. So -1 minus, and here inside this you have -1, so you are going to get -1 plus 1, that is nothing but 0, right? So it can be proven that 3 is the minimum number of operations that we need to perform, right? This is how we are getting this output. Okay, so here let's do one thing. These are the constants, right? Num1 is always starting from 1. Important point, num1 is always starting from 1, it is not starting from 0. So if it is starting from 1 and we need to make num1 equal to 0, right? So that means that we need some operations, right? So we have to do some operations, right? It may be 1, it may be 2, it may be 3, number of 3 operations, right? Like that, right? So at least 1 is required because it is starting from 1, not 0, right? And we have to make it 0, so at least one operation is required. Let's say in total k operations, let's say like this. Okay, now here after this what we have to do here, let's see, like this, 2i plus num2, right? So from num1, right, this is num1, from this what I have to subtract, I have to subtract like this 2, and here I 2 power I, and after this what we have plus num2, right? This is what we have to subtract, num2, right? Num2. So let's say this is my operation 1, right? So this is my operation 1. So now whatever the new value that I'm going to get from here, right, whatever the new value of num1 I'm going to get from here, so I can say my new num1 is equal to this part, right? This complete part, num1 minus 2 power I plus num2, right? So now this is operation 1. Now for next operation what you have to do, for next operation again you have to operate your num1 again. Num1 is equal to, here same thing like above, right? So here you are going to pass your num1 minus, and here 2 power I plus, and here you have to pass num2, right? So let's say this is your operation 2, right? So let's say in this way you are doing total k operations like this, right? So let's say this is nothing but operation k, and in operation k, do one thing. Let's do one thing. Instead of wasting time, let me just simply copy this and paste it here. So this is nothing but for operation k I am doing the same thing, right? So every time I'm updating num1, right? So here there is some other num1, right? So whatever the new value of num1 that I'm going to get, that I have to use here, and then again I have to do subtract, and then again I will get new num1. Then again whatever the new num1 I'm going to get, I'm going to place it here, and here I have to subtract, and then again I'm going to get a new one, a num1, right? So this we have to do until we get our num1 equal to 0, right? Okay, so here I can also write the same thing like this. What my target is 0, right? This is what I need. My target is 0, right? And uh, here my target is 0, right? And this is nothing but number of operations that I'm doing in total, right? So here first time my num1, this is my num1, and from this I'm subtracting 2 power I plus num2, right? This is what I'm doing. Okay, this is for very first time. This is what I'm doing, right? Now next time what I'm doing, first time I did this, next time what I'm doing, I'm going to, now this is going to act as my complete this num1, right? This is going to act as my complete num1, new value of num1, right? Now from this num1, right, from this num1 I have to subtract this part again, right? So here I can write it like this now, minus 2 power I plus num2, right? Making sense, right? So this is the first thing, right? num1 minus 2 power I plus num2, right? And this overall is nothing but num1, right? So here I can say this is nothing but my new num1, right? New num1. Then again I'm doing some operation, right? Operation 2. So num1, that simply means this value from that I'm writing here, right? In this value I'm placing this, right? I'm subtracting this minus 2 power I plus num2. So now this complete is going to be my next num1, right? This complete is going to be my next num1, right? Same way in the end, this num1 definitely it is coming from this k minus 1 operation, right? So let's say okay, in the end what I'm going to do, I have to do the same thing, right? I have to do the same thing until my kth operation, right? My kth operation. So let's say here I'm writing 2 power I plus num 2, right? And let's say here you can say this is one time, right? I1. So let's say this is operation 1 that I'm doing here. Here let's say I'm doing it for operation 2, right? And here let's say this is operation k. Okay, so total k operations, right? Clear until now? And my target is going to be 0, right? In the end this is what I need, this is the expectation, right? Target, it should be 0, right? Okay, so now here this is what I found, right? Equation. Now here what I can do after this, I can move my num1. Okay, I can move my num1, or what else I can do here, all these values are in minus only, right? So I can take all these values to some other side, right? So I can write it like this. Here see num1, right? Here num1 I'm writing, num1 is equal to, this is 0, right? So this value is in minus, this value is in minus, and this value is also in here I'm doing minus, right? I'm doing minus everywhere, right? So if I take all these values to your left hand side, so all these values will become positive, right? So I can say I can write it like this: 2i1 plus num2, and here this value it also goes to your left side, 2i2 plus this minus is going to become positive completely, right? So 2i plus num2, and this until here this is also going to become positive 2, and here I power k and plus num2. Okay, so here if you notice one more thing, this is for first operation I1, this is for second operation, right? This is for k operation. So here I'm using num2, here also I'm using num2, here also I'm using num2. So in total how many times I'm using num2? Total k times, right? So I can write it like this: num1 is equal to k times your num2, right? Plus, and here 2 I, here 1 2 and k, until k times I'm writing, right? So here let's write it like this, summation, right, 2 and here I, and let's say this is nothing but your you can say total k times, right? So let's say this is nothing but you can say j, right? And your j is from 1, right, and until k, right? So this is the equation I have formed now. I hope that this is clear, right? So you are clear, right, how we are forming this. So our target is going to be 0, right? And first time what we are doing, num1 minus 2 power I plus num2, right? So now treat this as complete as your num1. This num1 we are placing here, and from this again we are subtracting this. So num1 and again I'm subtracting this, right? Now operation 2s are done, two operations are done. Now in the end, same thing you have to do until k. Let's say with k I'm going to achieve my target 0, right? So that is why I'm taking 0. So now after that I'm just solving this equation, right? And in the end I'm going to get this formula, right? Okay. And also I can write it like this. I can write it like this also. Num1 minus, and this value goes to your left hand side. So k dot, and here num2 is equal to summation of j from 1 to k, and here to I and j, right? So this is your equation, right? Okay, so here what does this k is showing here? K is nothing but it is showing the number of operations, right, which we need to do, number of operations. Okay, and you can treat this complete. Okay, let's do one thing. You can treat this complete. Let me use this. Okay, so you can treat this complete as your target. Okay, this blue color, this one as your target. Okay, this is your target, right? All right, and this part, okay, this part here, if your j is from 1 to k, right? So you are doing some operation, right? But in all these operations that you are doing here, base is 2, it is fixed, base is fixed. Here we can have different type of values, right? Here we can have different values, right? And here in the problem statement it is saying that this value, right, in one operation you can choose integer I in the range 0 to 60. 0 to 60 you can use, right? 0 to 60. So 0 to 60 you can choose 0 to 60. Okay, so now here let's suppose you have values like this 13, right? So how you are going to write 13 in binary form? You are going to write like this 8 plus 4 plus 1. You can write it like this, which is nothing but like this, right? This bit value is 1, this bit value is 2, this bit value is 4, this bit value is 8. So you are going to write like this, clear, in binary form, right? This 13. So here in this 13, right, this is what you are writing, right? So this, so here you can say this is nothing but 2 power 3. This is the one power of 3, power of 2 you are using, right? 3 is the power of 2 that you are using here, and here you are using a power 2 for this 2, right, base 2, and here you are using 2 power 0, right? And you are getting this 13, right, with just 3 set bits, right? With just these 3 set bits, right? But here if you notice, 2 power 3 is 2 into 4, 2, and 4 into 2 8, right? And here 4 plus 1 13. Okay, this is right. All right, so now here if you see this example number 1 only, num1 is equal to 3, num1 is equal to 3, num1 is equal to 3, and what is the value of your num2? Num2 value is minus 2, right? So here num2 value is minus 2. Okay, done. Now here if you are doing one operation, let's say if you are doing just one operation, then can we make this equal to 0? Tell me, if I'm just doing one operation, right? So let's do one thing here. If I'm doing one operation, so just use this num1 is equal to num1 is 3, right? 3 minus, and one operation, k value is 1, right? One operation for k is equal to 1, k is equal to 1. Okay, one operation, 1 into num2, 1 into num2 is nothing but minus 2. So what I'm writing, 3 minus, and here this is nothing but minus 2, right? And here I'm getting 5. This is what I'm getting here, 5, right? Okay, 5 I'm getting, right? So now can I write this? Can I use the powers of 2 to get 5 here? Tell me, can I use the powers of 2 to get 5, right? But here only one operation I have to do. That is the twist. You may say that let's write it like this now, 1 2 4 8. I can write 5 like this. No, that is not the requirement. Okay, it is saying k is equal to 1. Only one operation you have to do. Only one operation. Only one time you have to write this part to get 5. So there is no way, right? There is no way to write this. Okay, there is no way, right? So here you can only write this 5, right? So in the target, okay, in the this side, in the RHS side, let's say this is nothing to your RHS. Okay, so in the RHS side, in the RHS side, to form 5, you can only write it like this: 2 power 0 plus 2 power 2, right? 2 power 2 is 4 plus 1 5. Only this way you can write, right? But here you are writing two times, na? This one time and this one time, right? This is not allowed, right? Only one operation, only one operation is the requirement here, right? Okay, next time let's see for k is equal to 2. K is equal to 2. So here for k is equal to 2, you are going to write it like this. Let's say 3 minus, and here two number of operations into minus 2, right? Okay, so here this is nothing but 3 minus 2 into 2 is minus 4, and 3 plus 4 is 7, right? Now you can do two operations. You can do two operations, but can you write 7 in two operations? Here only two operations you have to do, right? You have to use the powers of 2, right? Here, so you can write it like this: 2 power 0 plus here 7 you need now. So this should be set, right? Only then you are going to get 7. So 2 power 0 plus 2 power 1 plus 2 power 2, right? This is how you are going to get, right? So this is nothing but 1, this is nothing but 2, this is nothing but a 4, right? So you are going to get 7. But here only 2 you have to do. Only two operations you have to do. But here how many you are doing? You are doing in total 3, right? Not right. Okay, next time here for k is equal to 3, if you do, let's see, k is equal to 3, we need minimum, right? I'm starting from 1 only, 2 then 3. Okay, so now here 3 minus number of operations 3, and here we have num2 value as minus 2. So here I'm going to get 3 minus, and 3 minus 2 is minus 6. I'm going to get 9, and here k is equal to 3. Okay, now there is one more twist here. If you see 1 2 4 8, so here you can write it like this, right? 9. Okay, so you can write it like this. You are going to say 2 power 3 plus 2 power 0. Here we need 3, here we are just getting 2. So now you are going to say that this is wrong, this is also not valid, but this is valid. Okay, because what it is showing, for k is equal to 1 we are getting the 5 value, right? Here in this side we are getting 5 as target, right? Now in the RHS I am saying like this, okay, in the bits form. So this 2, it is showing nothing but the minimum number of bits required to form 5, right? Minimum number of bits 2, right? Here also for k is equal to 2, right, the output is 7, and in the RHS side when we need 7, so we need minimum 3, right? But we can't have 3, right? Here it is saying 2, right? So what does this mean actually? So here if I write, I can also write it like this. This is nothing but, this means you can say express this, or you can say uh, in express in sum of k powers of 2, right? Express in sum of k powers of 2, right? This is the meaning of this line, right? K powers of 2, right? So here just one power of 2 I want to represent, but it is not possible because we need minimum 2, right? In just 2 powers of 2, right, k powers of 2, right, we have to represent this target, but this is not possible because minimum required is 3. Here in just 3 powers of 2 I have to represent this sum, right? But here in 2 I'm getting, right? But this doesn't mean that I can't get in 3. I can get in 3 also if I write this same thing like this: 2 power 2 plus 2 power 2 plus 2 power 0. So this is nothing but 4 plus 4 plus 1, that is 9, right? So from here I conclude that if I just calculate the number of set bits of my target, calculate the number of set bits of my target, calculate the number of set bits of my target, then I will get the minimum number of powers of 2 that is required, right? Minimum. So here at least 2 is required, but with just 1 it is not possible, right? So we can't express this target in 1 power of 2, right? Only 1 power of 2, but we have to use 2 powers of 2, like 2 power 0, then 2 power 2, then only we can represent, right? So this is going to give me the minimum number of set bits, so that's why I have to count the number of set bits. Okay, and here see this k value is 1 and here 2, so this value is smaller than this, result is not possible, right? Here k is equal to 2 and it is smaller than this, result is not possible, but here result is possible, right? With k is equal to 3, right? uh, Here we are getting 2, right? Minimum number set bits 2, but with this answer is possible. So from here I can derive one thing, that my k value, okay, this my k value, it should be, it this value, it should be, I can say, greater than, right? This value, it should be greater than the minimum number of set bits, min set bits, right? It should be greater than or equal to also, I can say, right? This k value, right? Now it makes sense, right? So here in this case, the number of set bits for 7 I'm getting 3, but we have to express our target in k powers of 2, right? Only 2 powers of 2, but that is not possible because we need at least 3, right? So in this result is not possible, right? So I can, from this also I can say now that if my k value is greater than minimum number of set bits, then that's it, then there is no output, right? If k is greater than the minimum number of set bits, then output is not possible, right? So here that simply means I can say that if my k is greater than this min set bits, then just output is not possible, okay? Minimum set bits, okay? So this, and here one more thing, if I want to write, okay, this is in the, this I'm writing just 2 powers of 2, right? 2 powers of 2 here, so this is nothing but minimum, right? And in a max, how many number of powers of 2 I can use to express this 5? I can write it like this, 2 power 0 plus 2 power 0 plus 2 power 0 plus 2 power 0 plus 2 power 0. This is also nothing but 5, but this is nothing but the max, right? Max powers of k, right? Max power of not k, right? Here max powers I'm using to get the output equal to this 5, right? So to get the max, right? So in that case we have to use 0 here, right? So that I'm going to get 1 here, 1 here, 1 here, right? So same way here for 7, minimum number of bits required is you can say 3, right? 1, how you write 7 in binary form? 1 2 4 and 8, this is how you write, right? So minimum is 3, max is 7, right? If you write everything like this, 2 power 0 plus 2 power 0 plus 2 power 0 plus 2 power 0, we have to show it in the power of 2 only, right? Plus 2 power 0, right? So here 7 is the max, right? Okay, and here the max is 9. Okay, this is done. So for this k, for my output, right, I want my min set bits to be less than equal to this k, right? If this is the case, then simply return the output, simply return the output if this is the case, because we have to return the minimum number of operations, huh? So for k is equal to 1, the result is not possible. K is equal to 2, result is not possible. For k is equal to 3, result is possible, right? This is the first time result is possible. Just return k from here, right? Okay, clear. One more thing here, one more thing here, this complete target value, right? This complete target value, right? This complete target value, it should be less than k, right? So here I can say that your k value, it should not be greater than the target, okay? Or I can say target value less than k, or k value is greater than target, okay? Same thing, right? Why I'm saying this now? So here let's say your k value is 3, k's value is 3, and let's say the output that you are going to get here, the target is 2, let's say, not 9, I'm not taking this example. Let's say you are getting 2 with k is equal to 3, you are getting 2, let's say. So now you want to show this 2, right, in form of bits, right? In form of bits, and you must have show it in 3 operations, right? 3 operation. So even if you do the 3 operations like this using minimum value of 2 power, right, 0 only, then also you're going to get 3, and here you have 2. Result is not possible, right? Understand this thing, right? So what I'm saying here, if your target value, if your target value, let's say complete target value, right, is 5, let's say, okay, and your target, let's say it is less than k, and your k value is, let's say, 6, right? So now k is nothing but the number of operations. So can you express in sum of k powers of 2, right? Can you express this target, express this target, right, in k powers of 2? Can you show? No. 2 power 0, if even if you do minimum 2 power 0 plus 2 power 0 plus 2 power 0 2 plus 2 power 0, you're getting 6 only, right? Okay, clear? All right. So now here k is equal to 6, right? And now with k is equal to 6, answer is not possible. Next time, let's say you say k is equal to 7. With the 7 also, result is not going to be possible because your target is going to be smaller, right? Because this statement is in minus, right? So here let's say 8, and here first time you said 6, so you're going to get 2. Now in this second hand, if you use some bigger value, if you get some bigger value here 7, so your output is always decrementing, right? 8 minus 9 minus 1, 8 minus 10 minus 2. So k is in this side, right? So with increase in k value, right, your target will be always be reduced, right? So definitely your answer is not possible, right? So if with this case equal to 6, answer is not possible, I'm simply going to return from here. I'm going to break my loop, right? Because for any more case, result is not possible, right? This is the second observation that I have now, right? Okay, clear? All right, so this is done. Okay, so this is the formula that I have derived also. Okay, now here, so here we have to just check like first operation, second operation, third operation, right? Like this is what I have to check, right? So here if I move to the coding part, okay, so here I'm saying that I have to run one loop k, and number of operations minimum is going to be 1, right? And max, how many operations I need here, max, right? And here my k is running, right, every time. And inside this, what I'm going to do, I have to calculate the target, right? So how I'm going to calculate the target? So I'm going to calculate my target. This is my target, right? Target is nothing but num1 minus k into num2, right? And these values actually are very large if you see the constant size. Okay, so let's use long, right? So what I'm going to do here, long target is equal to, and here I'm going to write long, and here I'm going to write num1, the formula, right? And here long, and here I'm going to write k into num2, right? This is what we have to do. Okay, right? This is the formula, num1 minus k into num2, right? So once I get this target, then after that I have to make sure that if my target value is less than k, right? So here I've explained, right? So if target is less than k, then the output is not possible, right? Because we need minimum 6 operations, and if I use minimum power here 0, right, then also I will not get this target, right? So I will break it. If target is less than k, break it. This already clear, right? And for why I'm breaking it, because with increase in k values, my target will become more and more smaller, right? So that's why I'm breaking it. Okay, so if this is not the case, then how I'm going to calculate the minimum number of set bits? So in Java, it's very easy, right? Minimum number of set bits, you have to just calculate this inbuilt method, long dot bit count. So it is going to count the number of set bits, okay, of target we have to count, right? This is done. Okay, now here when you have to return the output, so here I told you that if k is equal to 1, minimum we need 2, right? So that is not possible, right? Minimum is 2, but we only need to do one operation. With k is equal to 2, here minimum required is 3, but you have to do only 2 operations, not possible. With k is equal to 3, here minimum required is 2, right? Minimum required is 2, right? So k value is bigger than this, right? So here this, right, min set bits is less than equal to k, that means this one. So here if I write if min set bits is less than equal to k, then in that case what I'm saying return k value, right? This is what I'm saying, right? And if you are not able to return this k value anywhere, then in that case the problem statement is saying that we have to return -1. That's it, right? So here with this you are clear, right? With this, so using this 3 operation, result is possible. Same way using this 2 power 0 plus 2 power 0 plus 2 power 0 until 9 times, right? Then also the answer is there, but we need only 3 operations, so 3 operation is possible. If with the 2 it is possible, then with 3 also it is going to be possible only, right? So we have to just make sure when my mean number of set bits is less than equal to k, then simply return k. That's it, right? Okay, now this what value should we fill here? What value should we fill here? That is the next question, right? So here, okay, so now here I can do one thing. Let's see what is the max value of target I'm going to get. Max value. So max value of this target I'm going to get when my num1 is max. This side I want max. So what is the max value of num1? 10 is per 9. Okay, 10 is to power 9. And here minus k is another number of operations. And here I need some value, but I want the overall result to be max. So here, what should I fill? So if I fill here minus 10 is to power 9, right, then this is in minus, so definitely if I write here minus 10 to power 9, so overall result will be positive, right? Here minus minus, it is going to become positive, so I can say 10 to power 9 plus k into 10 to power 9. This is what I'm going to get as maximum target. I can also write it like this 10 to power 9 1 plus k. Okay, so this is the maximum target I'm getting, right? Maximum target I'm getting. So maximum target that I'm getting is nothing but 10 to power 9 1 plus k. Okay, so this is the max target value. So here this target value we are coming from here, right? And here in this side we have to express in sum of k powers of 2, right? Sum of k powers of 2, right? So this thing I want approximate equal to 2 power k, right? Now here if you think like this, initially my k is equal to 0, this value is going to be 10 raised to power 9, and here 1 only, and here in this side this is nothing but 2 power 0, right? So yeah, then this is bigger, right? Initially this is bigger, then here 10 is to power 9, and here k for the next one, this is going to give me 2, and here this is nothing but 2 power 1, right? For k is equal to 1. So now here this is 1, and now it is going to become 2, then after that it is going to become 4, right? This is exponential, right? So 10 is to power 9 1 plus k, it grows linearly with k, and this grows exponentially with k, right? So initially this LHS is bigger and this RHS is smaller, right? This is the case, right? For small k, LHS is bigger, right? And then after some time I'm changing it like this. Initially we are getting something like this. Okay, let's say this, right? And then maybe after some time we are going to get something like this. Let's say after some time there may be one case when this is going to be the case, like just opposite of this. That's why I'm just writing here less than. So when this is going to shift, okay, then when this is going to shift, then that simply means at that particular time we are very close to k value. Okay, so here, so we are searching for the smallest k where the inequality holds. So if you just use like this, so you are going to get some k value approximate around 36, right, or 35. So k is equal to 35. 36 is the first integer where the inequality flips, and from there onwards it always holds. So there is some time like we are moving like this linearly, right? And in the graph, in RHS side, it is going to move like this exponentially. So then after it is going to increase continuously, right? And it is going to move like this, and it is going to increase continuously, right? So here you will get k value something around 36, right? So if I just put this k as 36 here, let's see if I'm able to pass all the test cases or not. Okay, if yes, then good. Let's see. So all the test cases has been accepted, right? Now if let's submit it. So see, our solution is accepted, right? In the LeetCode editorial, it is showing 60. So we can give that as well. Okay, you can run until here also, right? So I was trying different k values. So with k 60, 35, it is possible. With 32 also it is possible, right? Let's see. So with k is equal to 32, let's see if we are able to submit the code. So yes, with k is equal to 32 also we are able to submit, but with k is equal to 31, I think we are getting a few test cases failed. Let's see. So see, with k is equal to 31 we are getting this issue, right? But after that, so you can give any value here right from afterward, right? But I hope that you guys are clear what we are doing here, right? So I hope that you guys are clear with this problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.